Yeah, comes on everyone. Let's start off. Great. So last thing that we did, we were doing the springs and we wrote a general steps, how to find the time period for any system. It's not only for springs, for any system. How do you find the time period? Great. And last time I showed you this thing, series, parallel, everything. Hope everyone has gone through this. Great. Let's go ahead with a few questions. We have a block of mass m. This is, let's say, 2k. This is 2k, and this is k. Find the time period. Let's say this is 3k, this is 2k, and this is block m. This point here is, let's call point P. Find time period. Find time period. That is the first question. If the amplitude of the block is A, then find the amplitude of point P. So if this block is going up and down with an amplitude of A, again, remember the meaning of amplitude, the maximum distance from the mean position. So P is the point of intersection between the two strings. Yeah, let's get this. You guys remember, right? Last time we did that series, parallel, all that stuff. Yeah, first was easy. Yeah, the second one, amplitude, that's what I'm more keen on. So what are these two? These two are in series. Parallel. 2K, 2K are in parallel. When you are in parallel, what you do? For springs, when they're in parallel, you directly add them. When they're in series, it is 1 by k equivalent is 1 by k1 plus 1 by k2. So this can be replaced with one spring here, 2k, 2k, that will become 4k, and this will become k. And here the k equivalent will be k1, k2, that will be k into 4k by k plus 4k. That's 4k by 5. That means this whole system can be replaced with one spring whose spring constant is 4k by 5. If you have one spring and one block, the time period is 2 pi root over m by k equivalent. 2 pi root over 5m by 4k. Easy? That's a straightforward one. What about the second one? Find the amplitude of the point P. Time period is easy. So how to get the k equivalent here? So K equivalent will be 3K, 2K, 3K plus 2K, 6K by 5. The time period is root over 2 pi m by, so 5m by 6K. Now think about this. So if this spring stretches by x1 and if this spring stretches by x2, and this guy will go with an amplitude A. That means x1 plus x2 is equal to amplitude A. And plus, if you try to draw the FBD at point this thing, so this will be 3K x1, and this point is being pulled by 2K x2. Because the point is massless, the forces must be equal. So this is the second relation between them. 3K x1 is equal to 2K x2. So from here you get x2 is equal to 3x1 by 2. So if you go and substitute here, you end up with x1 will be 2a by 5. And this is the amplitude of point B, because whatever the 3K stretches, isn't that the displacement of point B? So if the upper spring stretches by 1 centimeter, then the point P will move 1 centimeter. So the elongation in 3K is the displacement of point P. Therefore, amplitude of point P is 2a by 5. So if the block oscillates with A, right? So this thing will oscillate with 2a by 5. Yeah, right, Anvita. Right, Samyak. All clear with this? The amplitude part? So both the springs will not stretch by A. They will stretch x1, x2, but the sum will be equal to A. Any doubts on this? Clear, no, Pratyasha? Clear? Sudiksha? Great. Let's see a few more. Let's say we have a block here. We have 3 springs here. K1, K2, K3. There is a floor at the bottom. I'm not drawing. Find the time period. We have a spring here. We have a block here. We have a spring here. The springs are not connected to the block. Find the time period. They're touching the block, but they're not attached. So the doubt comes here, what are these 3 in? Are they in series or parallel? Again, go back to the definition. How do you say something is in series? Just because they're side by side, don't say they're in series. To be in series, what is the condition? They should have same tension. For parallel, what is the condition? They should have same elongation. But if that looks confusing and if you're not sure, this is how we handle this kind of problems. So displace this block by X. Let's say if I displace this block by X, draw the forces on the block. What are the forces? This spring will push K2X. This spring will push K3X. Tell me one thing, are the forces same in the springs? The forces are not same, but the elongations and the compressions are same, K1X. All the forces are in the same direction. All these 3 springs are in parallel. So K1X plus K2X plus K3X is equal to minus MA. think about this. This K1 spring, if I take it from here and keep it on the right hand side, does it make any difference? Getting it? So K1 is not in series, K1 is also in parallel. So this would be K1 plus K2 plus K3 by M into X. That's your omega square. The time period is root over M by K1 plus K2 plus K3. So anytime you're confused whether it is series or parallel, go back to the basics. What are the basics? Displace the block by X. Draw the FBD, find the restoring forces, F is equal to MA, and you're done. What about D? Right, Samyak. Now in D, what happens because you're not attached? Now when this block goes to the left-hand side, see what happens. So when the block goes to the left-hand side, the K2 spring will be just there. It does nothing. So this will go from here to here, and this time period will be T1, which is 2 pi root over M by K. So when you're on the left-hand side, the time period is 2 pi root over M by K1. But if you go to the right-hand side, then K2 will push the block, K1 will do nothing. Then here the time period will be 2 pi root over M by K2. But you're doing half of this and half of the other one, isn't it? So if you look at your motion, when you're going left and right, you're doing half of this motion. And when you're going to the right hand side, you're doing half of this motion. So the total time period will be T1 by 2, T2 by 2. Pi into root over M by K1 plus pi into root over M by K2. Is that making sense? So when you're going on the left hand side, only the K1 will push. So it behaves as there is a spring K1 and mass M. But once you go to the right side, K1 will get disconnected and the K2 will start pushing you. Now it behaves like a system of K2 and M. But you're doing only half of each. All clear with this? It's a good one. It's a pretty good mains level question. Any doubts on this? So you'll get half of each. Clear, Shreyansh? Vanchika? Vedika? Shaurya? Ritisha? Clear with this? Same question. Let's say we have a block, we have a spring attached, and here we have a rubber band. Whose spring constant is K2. Now can you find the time period? We have a rubber band. Mm-hmm. Right, Arya. Right, Samyak. Try others. I'll give you a minute. These all are like, I'm keeping all of them together at one place. So like all good means ones. They're not really that out of the world. Nahi, Param, that is wrong. What is the catch? How does a rubber band and how does a spring behave? So that is a thing that you should realize. So the idea is this: a rubber band, when you stretch it, it will pull you back. Rubber band can pull, but it cannot push. So when rubber band is stretched, it behaves like a spring. But when you try to push the rubber band, when rubber band is pushed, it becomes loose. It does nothing basically. So how will your picture look? If I push this block to the left hand side, so when the block is pushed to the left hand side, this spring here will push with K1x. The rubber band will also pull with K2x. So it just behaves like two springs here. So this time period will be 2 pi root over m by K1 plus K2. Remember, both are in the same direction there. But when you push it to the right hand side, right, so this rubber band, right, will just become loose. It does nothing. So when you push it to the right, then you have only one force, which is K1x. So now the time period will be as if there is only one spring, 2 pi root over m by K1. Same story, you're doing half of this and half of the other one. So the time period will be T1 by 2 plus T2 by 2. I into root over m by K1 plus K2 plus pi into root over m by K1. Clear with this? Got how does the rubber band work? So the idea is important. Keep that in mind because later on rubber bands will come. So a rubber band, when you pull it, it acts like a spring, but when you push it, it becomes loose, so it does nothing. All clear with this? This is a PYQ, the easy one, but so we have a spring here, mass m k, and the time period is t. Then what you did, this is cut into 3 equal pieces. And this is how you keep them. You kept them like this. And the new time period is t2. Find t1 by t2. Yeah, easy one. Try 30 seconds more. In case you don't remember this thing I told you last time, you have to revise the notes. If you cut a spring, k into L remains constant. Mm. So what is the catch? So when you cut the spring constants become 3k, and you're keeping them in parallel. So here the time period t1 is 2 pi root over m by k. When you cut the spring here, k into L must be equal to the new spring k1 into L by 3. So the spring constant becomes 3k. So this each spring will have a spring constant of 3k. When you cut it, the spring constant increases, and upar se you kept it in parallel. So the time period t2 will be 2 pi root over m by 9k. So t1 by t2 is equal to 3. Be careful, it will become 3 times into again 3 times. Clear with this? Yeah, that's an easy one. That was an actual mains question. We have a spring here, k and L. You took some, some kind of mass or something, sticky substance, and you attached a mass m here. mass M is attached in the middle of the spring. So this distance will be 0.2L and this distance is 0.8L. So if it is displaced along the spring, find the time period. So if it is displaced left and right, what will be the time period? Four pi by 5. Okay, let's see. I don't remember the answer. 4 pi by 5. 4 by 5. Okay. Three people got the same thing. Maybe right. Others try. I'll give another 30-40 seconds. Okay, I think Govia also got the same thing. Okay, let's see. So what is the catch here? Since you're putting in the middle, you can just cut it off and put a block there. You can put a block here. And you can put a block here. Right? And so the springs will have different thing here. So this is K1 and this is K2. So K into L will be K1 into 0.8L. So K1 will be 5K by 4. K into L will be K2 into 0.2L, and then K2 will be 5K. So that's the main idea there. So basically you have created two different springs. And both of them are in parallel. So K equivalent will be K1 plus K2, and the time period will be 2 pi root over M by K equivalent. Clear this? You know where you have seen this question? You have seen this in laws of motion. ये question याद है? There was a spring and you applied a force at a midpoint somewhere at A and you pulled it. Find the the distance moved by A in equilibrium. This was the question there, which we did in NLM. So idea was the same. So there, if you see springs and all, that time you didn't realize, but this was the question. So this is page 188 NLM. So we have a block here, mass M, spring constant K. This is your mean position. And here there is a wall. And E is equal to 1, and this is X is equal to A by 2. So someone release the block from X is equal to minus A, extreme position. Find the time period. So you're not letting it complete a full oscillation. It hits a wall even before it goes to the right extreme. So if the wall was not there, you would have gone to plus A on the other side, but you hit the wall and you bounce back, and D is equal to 1. So there's no loss of energy. So if someone asks you what kind of motion is this is actually periodic motion. This is not SHM. Because when you hit the wall, the force is not restoring force, isn't it? The force is not proportional to x during the point of collision. So for that small time interval, it messes up the whole thing. Yeah, so what you can say is a partial SHM. So if you ignore the time interval during the collision, then the whole thing kind of looks like an SHM only. How do we do this? Get it? You have already done this before, you just don't realize it. Try. So how do we do this thing? So how does this motion go here? Just think about it. So from here to here, the time taken is t by 4. From here to here, the time taken is t by 12. And when you're coming back, it takes t by 12. And when you go back here, it takes t by 4. So the time period will be t by 2 plus t by 6, 2t by 3. And what is t? 2 by 3 into 2 pi root over m by q. Where did we do this thing? If you guys remember this question, remember this? We wrote the time intervals here. We have defined it from where to where, what is the time. And I told you how to get the times also. Ye question tha, if you remember, kind of like this question, isn't it? You're going from extreme to root 3a by 2. Making sense? So there's nothing to solve there. You know the time period is already 2 pi root or m by k, right? So when you hit the wall, this is what is happening. You will go with speed u, you will hit the wall and come back with u. So it gives you a feeling as if this right side part of the motion has vanished. Making sense? So it will, you just have to ignore the time interval after the wall to the x is equal to a. Finish off this and you'll get it. Clear with this? It's a pretty good question. Again, not tough, but mains and bits level questions these are. So you should really understand what is happening there. Most people will see the collision and they'll get scared. Any doubts on this? Clear, Shaunak? Devanshi? Advai? Next one. We have a spring and a block. System is in equilibrium. Then what you did, you took a block of mass 2m and then you attached it. You stuck it at the bottom. It's stuck on 2m and released. So it is already at rest and you stuck the block and you released it. Find the new time period and the amplitude of the motion. So if you attach the block and leave it, it's going to oscillate. So what is the amplitude of the motion and what is the new time period? Hmm, 3 mg by k, 2 mg by k. Time period is the easiest one, isn't it? Time period, it doesn't matter. Like you keep a block, let it oscillate, let it dance, let it do anything. Once you attach the block, this becomes the mass here becomes 3m. So the new time period will be 2 pi root over 3m by k. You might ask like, oh, but why doesn't it matter? If you go back to the steps, what was the first step? Choose your system and bring it to rest at the mean position. You're getting it? So it doesn't matter if it is initially already oscillating, you just stop it, you keep it at the mean position and you displace it. Are you getting it? So the time period will be simply 2 pi root over mass by k equivalent there. So it doesn't matter if it is already oscillating. The time period doesn't get affected because of the amplitude. Great. Now, the next part, you want to get the amplitude. Now, there's a very neat way to do this. Let's try to understand. This is your natural length initially, right? This position was your old mean position. So previously, the mean position used to be here. I'll call it old mean. And this distance was mg by k because initially kx was equal to mg. Okay. Now, when you attach the block, somewhere here will be your new mean position. What is the definition of mean position? F net must be 0. That means when you write kx is equal to 3 mg, so we get x is equal to 3 mg by k. But remember, this is from the natural length. So this distance here is 3 mg by k. So far clear, everyone? Now let me ask you something. When you attach the block and when you released it, what was the speed? The speed here was 0, isn't it? And can you tell me, during an SHM, at which point do you have 0 speed? At extreme position. Making sense? That means this old mean position is the new extreme position. Since the system starts from rest, that must be the extreme position. Because during an SHM, there are only 2 points when you will be at rest, the extreme position. Since the system starts from rest, the old mean position becomes the new extreme position. Then you're done. What is the amplitude? The distance between the extreme and the mean position. So that means this distance must be your amplitude. And therefore, we can get a amplitude is equal to 2 mg by k. Clear with us? Suppose if they ask this question, how much more it will travel, we can even say that. So it will travel amplitude a more. This will be the other extreme position. So the maximum elongation of the spring will be 3 mg by k plus 2 mg by k, 5 mg by k. Is this making sense? You could have done this from conservation of energy also. The gravitational potential energy lost by the block is equal to the spring energy and all that stuff. But this is more intuitive. You can just see and figure it out. Sure with this? Again, not a tough one, but that is how you get the amplitude. Generally, people have a problem with that amplitude thing. Any doubts on this? Great. Let's see one more. We have a block here. We have a spring here. We have a spring here. K, K, and K. This angle is theta and this angle is theta. So the block is displaced vertically by small x. Find the time period for small oscillations. When you say small oscillations, right, you can assume the theta will remain same. So you're not pushing it so much, the theta will change. Find time period for small oscillations. Since the oscillations are same, we can assume the theta almost remains same. Matlab, if it was 60 degrees, it would become 59.89 or something. So it's a very small change. So we have three springs like this, like a Y shape. Find the time period for small oscillations. Hmm. So what's the idea here? See, let's see first of all in more general. So if you have a block M, and let's say we have a spring at an angle theta, like this. Now look at the idea there. So if you displace this block by x in this direction, so if this point moves by distance x in this direction, then this spring will stretch. This will be also theta, and this would be x cos theta. That means if you pull the spring horizontally by x, along the spring, the displacement will be x cos theta. Spring stretches by x cos theta when block moves by x. What is theta here? Theta is the angle between the spring and the displacement. So it depends which way you're pushing the block, so the theta will change accordingly. That means now if you look at the FBD of this block, the spring force will be acting in this direction, which is k into x cos theta. Now we are only interested in the horizontal thing here. So again, if you look at the component of this force, this can be treated as kx cos theta ka cos theta. Kx cos theta, which is k cos square theta x. So basically, you can replace this entire system with one spring in the horizontal direction, whose spring constant is k cos square theta. Making sense? Again, this is only for small theta, small changes in theta. So if you have a spring at an angle theta, you can replace that with a spring of k cos square theta. Is that making sense? So two things are happening here. You are getting one cos theta because the entire displacement will not be x. The second cos theta is coming because k x cos theta ka one more component is coming. So you get a cos square theta there. So a spring at an angle can be replaced with a horizontal spring, right? Again, in the direction of the displacement. And now, when you see this question, now it becomes easy to handle. So you can just replace the two vertical springs with two vertical things like this. And one spring like this. So this spring is k cos square theta. This spring is k cos square theta. And this spring is k. And this problem looks like this one, isn't it? Doesn't it look like this problem here? The C problem, 14C. Then you're done. So what is the K equivalent here? All of them are in parallel. So K 2K cos square theta. Oh yeah, time period will be 2 pi root over m by K equivalent. So theta will be given different values. You can just put it there, 45, 60, whatever. All clear with this? So it will be cos square theta. Be careful with that. It's not one single cos theta. That's how you can handle the things with angle. Any doubts on this? Advait, clear with this? Ishman? Ovia? Param? Clear? Next one. So we have two blocks here. This is a spring constant K. The center of mass, we take it as origin x is equal to 0. Right? And this distance between them is L. L is the length of the spring in natural length. Now someone gave this block speed u, right? And the other block was initially at rest. Find the time period. Find the amplitude of the blocks. I hope you guys remember this question. Standard model in center of mass collisions. Find the oscillation energy. Find the coordinates of the block as function of time t. Initially, the center of mass is taken as origin. L is the length of the spring in natural length. The left block is given speed u. The right block was initially at rest. How does this motion go? In case you don't remember, you should definitely go back to the center of mass. We did this thing in pretty detailed. If you remember, we wrote this whole process. We wrote all the stages, that happens inside of this. If you, right, you should definitely check it out in case you don't remember. Page 134, center of mass collisions. This is what I keep telling you. You keep going back and front in physics. In a way, it's a good thing. You forgot, great. Now you'll go and revise. Now you'll learn it. You remember, that is great. Matlab, your entire portion is on your fingertips. Either way, it's a good thing. Instead of feeling bad, oh, I don't remember this, think, oh, good thing, right? You at least now you remember that you don't know, so you can go back and revise and learn. That's how you think. Because sitting and feeling bad about it will not help you, will do nothing. And anyway, everyone is doing the same thing, right? That's the reason they don't get results. If you also do the same thing, what is the point? When I was in 11th and 12th, right, few of my friends, especially in 11th, there used to be few people, right, who used to cry for every damn thing. Like, oh, my score is so bad, I scored less and everything. And they used to be depressed for 1 or 2 days. I used to feel very happy about it. Not because I was a psycho or something, but my logic was this. If this guy or person has time to sit and cry, but you're not going to go and learn from your mistakes and put some effort, right? You don't have time for all that, but you have time for sympathy, you have time to sit and cry, and you have time to sit and feel bad. So that guy, there is no way that person can beat me in any competition, isn't it? It's not like I don't feel bad. I feel bad, but then get back to work. Feel bad and get back to work. Why can't you feel bad and still do the work? When you feel bad, can't you watch Netflix and eat ice cream? You can do that, right? When you're feeling bad, you can sit in front of a Netflix or Durandar movie and you can eat ice cream. You can do that. So why can't you just feel bad and then still continue to study? As simple as that. if you're really that depressed, you should just sit and do nothing. You should just keep staring into the wall like that. You don't want to do that shit. You want to go and sit in front of Netflix or watch some stupid shit and then eat ice cream and eat pizza and stuff. That's not depression. You're just escaping from it. Yeah, you're still depressed. One thing I would suggest is like get to a gym, go and do workout, boys and girls, anything. That really helps. All your frustration and anger, show it on that weights. That's a very creative way of putting energy. You're more depressed you are, you should definitely hit your gym. Lift weights. You can lift 15 kgs now, lift 25. Your body will be in so much pain. Chup chap, you'll come home and sleep. You will not have any energy to think of any negative stuff. Right? So helps a lot. I still remember at some point in time, I was depressed for 2-3 days, I guess. I got so pissed off, I just went out for a walk. I walked around 22 kilometers and then I came back home. All the depression was gone. Simple. Next day, again, I felt like I'm going to get depressed. I went for 15-kilometer walk. I came back home. Depression was gone. After third day, I felt like, yeah, let's not get depressed. I have to walk so much bloody. Like, so yeah, the problem was solved. I got back to work. Give something for your body when you're feeling bad about it. Don't sit and watch. Don't give it comfort. You guys still have a lot of time. We still have more than 7 to 8 months. We can turn this around. So please put some work, get it done. I'm looking at your seniors, right? Yeah, they're putting a lot of effort. And unfortunately for them, it is pretty stressed out. I think it will be the same for you guys also next year. It is the first time it is happening. Things got literally packed actually. Unka mains to be starting from April 2nd. I told you this thing, I guess. April 2 to 9, JEE mains exam is going on. I think 11 say 15 or 16 CET exam is going on. And then 17 to 19 BITS exam is going on. So there was no time. And I think 19 or 20 UG exam is going. UG is the IIIT Hyderabad. So they literally packed back-to-back exams. And again, May first week, there is one more CET, and there is also Manipal, Vellore, all the colleges, and then advance is there on 17, and 24th is the second bits, and you're done. 24th is the last exam for them. So currently, most of them are putting almost 11 to 12 hours per day. They're doing nothing, sleeping, waking up, studying, eating, sleeping, studying, yeah, and 45 minutes of workout. 12 hours per day. How to do this thing? Did everyone got the time period? That is the easiest one. Yeah, but still you have to think about it. It is really, this question will be a very good advanced paragraph question. So here, look at this motion here. Because of the spring force, the block M and 2M will be having accelerations. They'll be going somewhat weird. But there is one guy in the system who is going with constant velocity. Who? Center of mass, isn't it? So if you can go and stand on the center of mass, isn't it an inertial frame? Anything that is going with a constant velocity is an inertial frame, right? And if there is no acceleration, matlab pseudo force nahi hai. So let's solve with respect to the center of mass. So the center of mass will be somewhere here. So if you go and stand on the center of mass, the velocity of center of mass will be mu by total mass, which is u by 3, right? And the COM is an inertial frame. So center of mass will think, okay, I am at rest, and these two blocks are moving about me, right? So if you look at from the center of mass frame, this is how the scenario will look like. So with respect to the COM, now the center of mass will think, okay, I'm fixed, I'm not moving, right? I'm at rest. But with respect to me, this guy is coming with a speed of u by 3, and this guy is coming with a speed of 2u by 3. Isn't it relative velocity? Because initially, what was the speed of this blocks? This was going with u, and this was at rest. So if you stand on the center of mass frame, relative velocity, the center of mass will think m is coming with 2u by 3 and 2m is coming with u by 3. Make sense? And also the center of mass is fixed point. So can I just do like this? I will just cut off the spring here and I will assume there is a spring attached here to this block. And I'll assume there's a spring attached to this block. Can I do that? Because that point is anywhere not moving. This point is fixed. Can I just cut it there? Now this question has become like one spring and one block problem, isn't it? And what is the length of the springs? The center of mass will divide them in the opposite ratio. So this is L by 3 and this is 2L by 3. That means this spring constant will be 3K by 2 and this spring constant will be 3K. So the time period of this block will be 2 pi root over 2m by 3K. The time period of this block will be 2 pi root over m by 3K by 2. It will be the same. The time period has to be the same. Are you clear, everyone? How we got the time period? Any doubts on this? Did everyone got the logic what we're trying to do? If you go and stand on the center of mass, it is an inertial frame. And the center of mass will think I'm not moving. So that point on the spring looks like it is fixed. So why don't you just cut it? And if you cut it, it has become simply one block and one spring. Yeah, new spring constants will come. K into L is constant. And then you're done. All clear with this? How do you get the amplitude? Think about it. Isn't this speed Vmax? So what is the amplitude here? A2 into omega? Because at that point, isn't that the maximum speed of the system? Because the spring is in natural length, isn't it? So here, the maximum speed of the 2m block is u by 3, which is nothing but the amplitude of the block into omega. So both the blocks will have different maximum speeds. Again, this is all with respect to the center of mass. So what is omega? Omega, we already know. Omega is root over 3k by 2m. You're done. Therefore, I got A2 is equal to u by 3 omega. Similarly, the maximum speed of m is 2u by 3, which is the amplitude of the block into omega. So both the blocks will have different amplitude. There I got the amplitude also. This is maximum speed with respect to com. Any doubts on this page, please ask me. All clear with this? So this is how you actually do this problem. Go and stand on the center of mass, cut it there, and you'll get two pieces. Now you can make a general formula out of it. You can take it as mass m1 and mass m2, and you can do this. So do remember the result for mains of bits. It will be very useful. So if you have m1, and if you have m2, and let's say this speed is u1 and this speed is u2, this is a more general thing, right? I hope you guys remember this. We did this thing in center of mass also. I gave you a general formula for this. Can you guys remember this box? Half k x max square is half mu v relative square. Mu is called reduced mass. So we have done that in com. So it again comes back. So for this thing, the time period is given by 2 pi root over mu by k. Mu is nothing but m1, m2 by m1 plus m2. This is the reduced mass. Helps a lot in mains or bits. Like they do ask questions of this sort. You know the formula, you'll get the answer pretty fast. So that is one. Second thing, what is the kinetic energy of the system? This we did in rotation, if you remember. Kinetic energy of a system is kinetic energy of center of mass because it is doing the translation plus kinetic energy about center of mass. Do you guys remember this? Kinetic energy of system is kinetic energy of center of mass plus about center of mass. I think we did it here. There, this was the thing. This is what I said that day. I said potential energy of the system is potential energy of center of mass. But kinetic energy of the system need not be kinetic energy of center of mass. And this is the proof for that. If you have taken n different particles, different velocities, and then we do all this, and this is the thing we got. So kinetic energy of a system is kinetic energy of center of mass plus kinetic energy about center of mass. So you can split the motion into center of mass and with respect to the center of mass. This is page 90. You should definitely refer this. Now in this, if you observe something, so this is your kinetic energy of the system. This component here is constant. Why is this constant? Because center of mass velocity is not changing. Since Vcom does not change. That means whatever energy is going into the spring, that is going only with respect to this, isn't it? This component of energy is becoming the spring ka potential energy. This is the component of energy. So among the total energy, there's a part of the energy which will not change, and a part of the energy is going into the spring and coming out of the spring, which moves between the kinetic energy to the spring potential energy. And spring potential into kinetic energy. And this is what we call as oscillation energy. Is that making sense? So in our question, so what is this value here? So this is your half mu square. What was this thing? Half center of mass. That would be 3m Vcom square. So whatever is the balance is your oscillation energy. Clear with this? So there is a formula for this also. We can actually calculate this also. So that means the maximum oscillation energy goes where? So the maximum spring energy is nothing but the oscillation energy. Because initially spring was the natural length, all the energy that goes into the spring must be coming from that component only. And this is nothing but half k x max square is the oscillation energy. And if you guys remember, what is this? This is nothing but half mu v relative square. Again, mu is your reduced mass. So all connected to the center of mass. And v relative is v1 minus v2. So in our case, the oscillation energy will be half, the reduced mass will be m into 2m by 2m plus m, and v relative will be u minus 0 ka square. That would be mu square by 3. Are you getting how all things are getting connected? If you guys remember, again, the same thing. This was the derivation for this. There. The maximum spring energy half k x max square is equal to half mu v relative square. So this entire problem, right, we have taken it from this one. You should definitely go back, revise this entire problem, make sure to go step by step. This is important because this thing is again going to come in, it comes in something called LC oscillations. Later on, we have a chapter in electromagnetic induction. This idea is pretty important, keeps popping up. Again, let me explain the whole thing. Listen carefully. Question abhi tak hua nahi. We still have to find the coordinates. So first thing, you got a block here, you're sending with u. What did we say? We said everyone is going with different accelerations, but the center of mass is going with constant velocity, right? Guys, I'm going to start removing you from the classroom. So I'm not sure why you guys need to keep your cams off for every 5 minutes, and I have to keep telling you. Right? Some people say 2 minutes, but I keep saying it's like 10, 15 minutes, you don't keep it on. So I'll just start removing from the classroom. So yeah, please don't feel bad. So when you stand on the center of mass, right? So it goes with a constant velocity, so it is an inertial frame. So it behaves as if that point on the spring is fixed. So I can just cut it off. I got 2 springs and 2 blocks. I got the time period. And interestingly, at that time, because the spring was in natural length, the speeds are also the maximum speeds, and that gave you the amplitudes. And then how do you find the oscillation energy? Think about this thing. Initially, spring was in natural length. Finally, spring has a maximum compression. So where did you get this energy from? When the spring has maximum potential energy, did the block stop? Do you guys remember that when do springs get maximum compression? There is a statement we proved it. The spring will have maximum compression when both the blocks have same velocity. याद है वो statement? Both the blocks cannot come to rest. Why? नहीं तो momentum conserve नहीं होगा. If both the blocks come to rest, then the momentum becomes zero. But initial momentum is mu, so it doesn't work. So maximum compression of the spring will occur when both the blocks have same velocity. That means if the blocks have some velocity, that means all the energy didn't go into the spring. Some part of the energy went into the spring, some part of the energy remained as kinetic energy. So that component of energy which went into the spring was the oscillation energy. Is that argument making sense? So indirectly, what you're asking me is to find the maximum spring potential energy. So it is half k x max square. And that you know how to find, meaning, and there's a shortcut for this thing, half mu v relative square, and you're done. Clear? You can handle that way. Or you can also argue the kinetic energy of a system is kinetic energy of center of mass plus about center of mass. Since center of mass velocity is anyway constant, that means only this part of the energy is changing. So that I can also calculate. Either way, it works. All clear with this? How do you get the coordinates? So if I have to ask this an advanced question, right, I'll ask you oscillation energy and I'll ask you the coordinates. That would be an advanced paragraph. At your level right now, that's a really good, tough question. I would say like 8 out of 10. But when you're in 12th, after the revision gets over, this will be like 4 out of 10. Now for your seniors, revision is going on, right? So this would be like a starter problem for them. So they're getting slaughtered in the advanced revision anyways. How do you find the coordinates? Again, think about it. It's very difficult to see the blocks because they're going randomly. But you have your center of mass, isn't it? What is the speed of the center of mass? Constant. So can you find the coordinates of center of mass? You can find. So go and stand on the center of mass, and can you look at the motion of both the blocks? They're going in SHM. You know the equation of SHM? So how do we do that? See, for the D part, the coordinates. This is the center of mass. Okay. Now for this block, this is the mean position. And it is oscillating. It's coming which way? It's coming this way. So this equation will be x2 is equal to a2 sine omega t plus pi, because it's going to the left hand side. This block is going this way, so this block coordinate will be x1. Again, from the mean position, this is the displacement from mean. X1 will be a1 sine omega t. I know omega, I know a1, I know a2. And this distance is L by 3. And this distance is 12 by 3. So the x coordinate of block M will be the x coordinate of center of mass minus 12 by 3, because you are behind, plus a1 sine omega t. And what is x center of mass? X center of mass is v-com into t, which is u by 3t. Therefore, the coordinates of this block will be ut by 3 minus 12 by 3, because initially you're 12 by 3 behind, plus a1 sine omega t, because you're oscillating in SHM. Similarly, the x coordinate of this block, again, x center of mass plus L by 3, your L by 3 ahead of center of mass, plus A2 sine omega t plus pi. So this is ut by 3 plus L by 3 minus A2 sine omega t. That's how you get the coordinates. Making sense? So first imagine the springs are not oscillating. Then what will be the coordinates? Center mass coordinate plus L by 3, center mass coordinate minus 2 L by 3, isn't it? If there are no oscillations, isn't that the coordinates of both the blocks? If there is an oscillation from the mean position, what is the coordinate? A sine omega t. Add them up and you are done. Are you getting how we got the coordinates? Just have a look at this. It's a good one. And why it is plus pi? Because you're going on the left hand side. We are taking right as positive extreme and left as the negative extreme. Any doubts on this? You should definitely try this problem again on your own. Any doubts? Take a break. Come back by 9:45. We'll continue from here. So we got a rhombus made of light rods here. The rods do not have any mass. But there is a spring between the two corners along the diagonal there. Length L. With the spring as shown. So these corners here, they're actually movable hinges. So gravity is present, meaning the picture will look like this, everyone. Now, if you pull the block, this will become like this. You getting it? So this is what will happen. So basically, these both the sides will get compressed. You're getting how it is? So if you pull the block and leave it, the spring in the middle will compress. Now, if the block is pulled down by small x, again, small oscillations, so whenever there's a small x, right, you can assume the theta doesn't change. Find the time period. So whenever you pull this block down, the spring will get compressed. Yeah, anyway, the spring is already compressed, you're getting it. Initially, it isn't at rest. So because of the weight, it is already compressed. When you pull it, it will compress more. If the block is pulled down by small x, find time period. Near area. That's not the answer. I'll tell you something. Think from this thing. Okay. Let's say like this. Let's say if I pull this down by y, can you tell me what will be the compression in the spring? Do you think it will compress by y? We don't know, right? There's no guarantee it will compress by y. Can you find that first of all? Start from there. If you pull the block down by x or y, what will be the compression in the spring? And let this thing as y, okay, because it's in y direction. Start from there. If you pull the block down by y, what will be the compression in the spring? Let's see. This is a bit of a geometry, everyone. So this is a rhombus. Let's say this whole distance here, this is your y. This is your x. This is theta. This is L. So this is L cos theta. This is L sin theta. That means x is equal to 2L cos theta. So if I do dx, we'll get minus 2L sin theta d theta. Y is equal to 2L sin theta. So dy is 2L cos theta d theta. Then if you just divide them, you will end up with dx by dy is equal to minus tan theta. Now understand the meaning of this. So dx is minus dy tan theta. So what is the meaning of this? If I pull this thing by dy downward, right, the spring compresses by what do you call it? Dy tan theta. See, you're not pulling the block by y, you're pulling the block by a small displacement, isn't it? So when y changes by dy, then x will change by dx. Is that making sense? If this block is pulled down by a small distance, then by what distance will the spring get compressed? Is that making sense? So when block moves down by dy, that means when you increase y by dy, right, then the spring compresses by dx. So the minus sign indicates compression, that x is decreasing. Spring compresses by dx. That is dy tan theta. The negative indicates x is decreasing. Is this clear, everyone? So whenever you pull the block down by y, the spring compresses by y tan theta. All clear with this? Now, coming back to the question. So that is the first thing you need to prove. If you pull the block by x, how much will the spring compress? So if I pull this down by y, the spring here will compress by y tan theta. Now be careful, this is the additional compression. Getting it? This is the extra compression. Remember, we are always going to draw FBD of change in forces. We are not going to draw the complete FBD. So we are going to draw the FBD of change in forces because the restoring force is simply the change in forces. So look at this junction here. So at this point, we have tension. We have tension. Again, what is T here? T is the change in tension. Already there is some tension. Now, because you pulled it, the tension changed by some delta T. I'm writing it as T, right? And the spring here is pushing with K into y tan theta. This is the spring force. Again, this is also change in spring force. All these are changes. If that is theta, then this would be 90 minus theta and 90 minus theta. Similarly, tension, tension. This is theta, this is theta. We are not writing mg since mg does not change. And this is your acceleration. Perfect. So since that is in equilibrium, 2t cos 90 minus theta is equal to ky tan theta. So from here we get tension is equal to ky tan theta by 2 sin theta. What about this thing? 2t cos theta is equal to minus mass into acceleration. Take this t and substitute here. I missed something here. When you pull it by y down, String. Arey yaar, I messed up everything. This was L sine theta. This was L cos theta. This was y. This was dy. This was x. This was dx. The dx by dy was cot theta. I was thinking, why is it getting cancelled? So the spring compression was y cot theta. Take this and substitute here. So this would be ky cot square theta is equal to minus ma. You're there, done. Minus k cot square theta by m into y. This is your omega square. Therefore, you get time period is equal to 2 pi root over m by k cot square theta. So the most important thing is this. If you pull the block down by dy, what will be the compression in the string? Dx. Clear with that? This comes from pure max, okay? We did nothing new here. And then we just do an FBD. Since the rods are massless, the net force on this junction should be 0. From there, you'll get the tension ka value. Then you'll take the net tension force on the block that must be equal to ma, and you're done. मेरे उत्साह देखो ना, एक और cos theta है. Cot square theta this is. Any doubts on this? Sudiksha, are you there? Adjust your camera, but I can't see you. Utsa, clear with this? Shreyan, Ishman, Anvita, Arya,
Yes, sir.
Arya, clear with this? Ovia, Samya, clear with this? Let's see one more. So that's again another pretty good one. This could be an integer question. We have a block of mass m. So we have this is a massless pan. And this thing is released from a certain height. Gravity is present. Find the time period. You're getting what is happening here? The block will fall on the spring will compress, then the spring will push the block up, and the block will fly again, and then will again come down. This will just keep happening forever. So what is the time period of this oscillation? Again, another good advanced level question. Think. I'll give 2-3 minutes. Let's see whether you will get it right or you'll fall into the trap. How do we do this? Chalo, everyone should give it a try. Once you're done scratching your head, let's start solving. Hmm. Solve. After getting the trap, what are you doing? Solve now. Why are you like you're in the, you're chilling out like as if you're in a park and enjoying the beauty of the gardens and everything. Solve. Physics class is anyway not such a beautiful place where you can chill out. And I don't like to see you guys being so happy. Solve. Solve the questions. Next week, say your juniors are also coming. I'm so pretty packed actually. Your seniors still didn't go. Your juniors are coming. So it has become 3 batches now for almost another 1 month. Did you guys get what is happening? You always have to draw a picture. And you might think like, oh, this thing is like something new. This is not new. Where you have seen this? Walk power energy. ये question याद है? Find the maximum compression in the spring. This will hidden work power energy. Something similar. Like I said, during that time I couldn't ask you to find time and all, but now we can. So let's draw the picture and let's see whether you fell into the trap or not. This is something I keep telling you, if you can't draw the picture, if you don't understand what is happening with the whole thing, you can't solve the problem. So let's define certain things clearly. So this is the natural length of the spring. So this guy is going to fall from here to here. Let this time be t1. How much is this? Root over 2h by g. This comes from kinematics, where h is equal to 2mg by k. That is given in the question. Agreed with that? That comes from kinematics when you release it from the thing. Now, when the block comes and hits the spring, be careful. This is still the natural length of the spring. This is not the mean position. What is the definition of mean position? The point where the net force is 0. Natural length is not the mean position. So what most people will do, they think it is going from here to the extreme and they'll think this is t by 4 and t by 4. You're getting the problem there? So this block will go further down somewhere here. At this position, this is your mean position. And how much is this distance? X is equal to mg by k. You're getting the catch? Then the block will still go further and eventually it will stop. This is your extreme position. And this would be your amplitude. So now the problem is, so from this natural length to here, this time is t2, which I don't know. From mean position to extreme, this time is t by 4, that I know. So the total time period of this will be root over 2h by g plus t2 plus t by 4. This is one-way journey into 2 to go back to the initial position. And the time period t is nothing but 2 pi root over m by k, one spring and one block. So the question comes, how do you find t2? Did you get the trap, everyone? So most people will think the natural length is the mean position. So they will write from here to here is t/4. So from the natural length to the mean position, we don't know the time. That's a part of an SHM, but I don't know the time. All clear with the steps? You're getting what are the catch? That's it. That is the most common mistake. They think the natural length is the mean position. How do you find T2? Just get the equation. It is a little lengthy.
सर वो साइन इनवर्स में आएगा ना?
Sin inverse में आएगा. Anyone didn't understand the picture, please ask me. So maybe I'll write T2 and T4 on the side here. Looks confusing. This is T2. This is T/4. So how do you find A first? You need to find A. A आ गया तो T2 आ जाएगा. How will you apply kinematics here? God, the acceleration is not changing. So how do you find amplitude A? Conservation of energy. Let this be state 1. Let this be state 2. Right? So you can just ignore everything else here. So I'm only taking these two places here, state 1 and state 2. So loss in potential energy is equal to gain in kinetic energy. Loss in gravitational potential energy, actually not this one, wait. This is my state 1. I can directly conserve energy from here to here. So from here to here, I can conserve energy. So what is the gravitational potential energy? I will take the natural length as a reference line, mgh. Kinetic energy, 0. Spring energy, 0. What is the gravitational potential energy here? It's going down to minus mg a plus mg by k. What is the kinetic energy? 0, because you came to the extreme position. What is the spring energy? Half k x square. X is the total compression from the natural length, which is again a plus mg by k. Energy in state 1 is equal to energy in state 2. You get mgh is equal to minus mg a plus mg by k plus half k a plus mg by k whole square. Solve this, you'll get Eka value from here. Now, once you got Eka value from here, then we can use SSM equation, x is equal to a sine omega t. Here, x is nothing but from the natural length, which is mg by k, is equal to a sine omega t2. So you get t2 is equal to 1 by omega sine inverse mg by ak. Clear with this? So once you got the amplitude, then the question has become like, how much time will it take to go from mg by k to the mean position, isn't it? I can use your sine equation, SSM equation, and finish it off. Yeah, you need to find the Eka value. I don't know whether you'll get a good value or not. You need to check. I think you'll get a quadratic. Are you clear with the steps, everyone? That's what makes this problem a really good one. That part. Most people miss that natural length to mean position part. Clear? Satyasha? Clear? Srihari? Vanshika? Clear? Aditi? Perfect. Next one. So we have a pulley, we have a spring. This is a smooth massless pulley. These are smooth pulleys, huh? They don't rotate. Find the time period. For small oscillations. Get this thing. This is a easy one. There is actually comes after this. I'll give you a way to get this thing much faster. Okay, good. The next one. First one is straightforward. Pull the block by X. Then the spring also will stretch by X. So this point will be tension. This point will be Kx. Remember, all these are change in forces. So this will be tension. So this is change in tension. Kx is the change in spring force. All these are changes. So we'll not write mg again. Acceleration. So t is equal to minus ma, and t is equal to kx because that point is at massless. So kx is equal to minus ma, and we get a is equal to minus k by mx. Yeah, it just looks like one spring and one block. Not much of a difference. But what about B part? What if you keep the spring attached to the pulley? Oh, yeah, Samyak, that looks right. What if there is a spring here also, Samyak? You have a spring here, you have a spring there also. Others, let's get this. I'll show you that next. How will you find the time period for this thing? Again, my simple question. If I pull this by X, do you think spring will stretch by X? Spring will go how much then? X by 2. Yeah, the constraints. Again, how did you get that? In case you're confused, look at the picture. You can just see from the picture. Just look at from the center, okay? If I pull this pulley, let's say the pulley goes down, I'm just exaggerating the figure here. So ask yourself this question. When this thing moves here, what happened to this string here and what happened to this string here? All the string that used to be here. So when I moved this by X down, or let's say Y down, so you got Y here and Y here. So this block will go down by 2Y. Making sense? So whenever the pulley comes down, you can see there is a string on both the sets which is getting loose, isn't it? Can you see the picture there? When the pulley comes down, this green part which I'm marking here, that entire string becomes loose. So whenever the spring stretches by Y, this thing comes down by 2Y. When spring stretches by Y, right, there will be a 2Y loose string. The string will become loose by 2Y. Clear with this? Then what are the forces then? So if you take the pulley, so this force will be kx by 2. This will be tension. This will be tension. So we get tension is equal to kx by 4. Tension is equal to mass into acceleration. We get acceleration is equal to minus k by 4m into x. Therefore, the time period will be 2 pi root over 4m by k. So two things happen. The elongation becomes half and the force again becomes half because there are two strings. All clear with this? No, but there's a very neat trick, to solve these things. Again, if you go back to NLM, if you remember, did we do that? No, not in NLM. I think we did this in work per energy, I guess. Not sure. Nope, I left it for this chapter only. Okay, let's see. Now, there's a shortcut here. Remember this, quite useful. You can use this even in NLM also. Equivalent spring constant. So the formula is this. I'll give you the formula. Derivation is not important, but I'll just tell you how it comes. T square by K equivalent is T1 square by K1, T2 square by K2, so on till Tn square by Kn. So here, capital T is the total tension on the block. Tn is the tension on the nth spring. T1 is the tension in the first spring, T2 is the tension in the second spring, and so on. So if there are 20 springs, you can still use this. Only problem, this is valid only for one block in smooth pulleys. You should have only one block, you can have 1,000 springs and this will still work. Valid for one block and smooth massless pulleys. You should definitely mug up this result. Saves you a lot of time, quite useful. Later on in other chapters also like NLM and all, you can use this. So how did this come actually? So I'll just tell you an idea. See, if there are n springs, the energy of the system will be half k1 x1 square plus half k2 x2 square. So on, I can write this all energy in the system is equal to half k equivalent x square. I can do something like this. I'm just conserving energy. I'm saying the energy in all the springs must be equal to energy in one new spring. Multiply and divide by k. So k1 square by k1, k2 square by k2, and so on. But what is k1 x1? Tension square by 2k1. What is k2 x2 square? Tension square by 2k2. This will be tension square by 2k equivalent. 2 will cancel everywhere. You get this formula. Getting the idea? It actually comes from conservation of energy. So your logic is if total energy in all the springs must be equal to energy in the one spring. Let's see how this formula works. Listen, I'll show you an example and let's do a few questions on this. The one which we did right now, this question. There's only one spring here. So how do we start? Let the tension be T in any string. It doesn't matter. Huh? You can choose T anywhere you want. I will choose tension T on the block. If this is T and this is T, what is the tension in the spring? 2T. Now apply the formula. T square, that is the tension on the block, by K equivalent. 2T is the tension in the spring, 2T square by K. There is only one spring. Therefore, K equivalent is equal to K by 4. Therefore, the time period will be 2 pi root over 4m by K. Same thing. You get the answer. All that story, right? The spring will stretch that much, that this, everything is taken care of. Yeah, but like I said, it works only when there is one block. Got the idea? I'll give you a few more models on this. Now you guys tell me what will be the answer for this. So using this, it saves your time. Let's say you have a spring here and we have a spring here. Let's say this is K1 and K2. Find the time period. Find the time period. So look at the B question. You will die if you see a question like that. You will not know who is moving what and all, but this method will save you time. Again, look at the formula here. T square by K equivalent. T is the total tension on the block is equal to T1 square plus T2 square, T1 square by K1 plus T2 square, this thing, and so on. Wait, we can do something even more interesting here. Huh. Did you guys get the first one? Look at this. Step one, let the tension be T anywhere. It doesn't matter. You take any string, it takes care of it. I will take tension T here. So this spring tension is also T because it is the same string, but this will be 2T. Apply the formula T square by K equivalent. So in the K1 spring, tension is T only, so T square by K1. In the K2 spring, the tension is 2T square by K2. There, you're done. So 1 by K equivalent is 1 by K1 plus 4 by K2. The time period will be 2 pi root over M by K equivalent. Substitute and you'll get the answer. Sure, everyone? What about the next one? You can take the tension T anywhere, it works. Like where you want to take the tension? The block or some spring, anything you can take. So let's say I'll take the tension T here. So if I take this as T, then this will be T by 2 and this will be T by 2 because there are two strings. If this is T by 2, T by 2, this is also T by 2, then this spring will be 3T by 2. If this is T by 2, this is T. This is T by 2. This is again T by 4. So that is the first thing. You need to know how to distribute your tensions. It comes from NLM. Okay, and then T square, the block is K equivalent. Let's go from here. This spring, tension is 3T by 2. Yeah, numbers are a little bad. Then the next spring is T square by K. Then the next spring is T by 2 whole square by 2K. Please check your terms. If you got this, then you got it. Then that last spring is T by 4 whole square by K. Yeah, I don't think you'll get a good one. I'm not sure though. It will be 9 by 4K, 1 by K, 1 by 8K, 1 by 16K. Please check this. So once you got it, you're done. You'll get the answer. Clear with this, Shreyansh? Param? Devanshi? Ishman? Arya? Clear? Samyak? Any doubts on this thing? So this method works beautifully, but like I said, should have only one block and pulley should be massless. All clear with this? Let's see one more like this. And if you got that, then I'm sure you'll got it. Find the time period of this guy. Wait, I'll do one thing. Let me put as K1, K2, K3 because you'll get confused what is K and all. Anyway, you just have to find the K equivalent. No need to simplify. Let's see how will you find time period for this. How do you start? Start with tension T anywhere. So let this tension be T. I'll start from here. If that is T, this is also T, this is also T, then this guy will be 2T. If this is T and this is T, this is also 2T, this is a T and this is T. And this is 2T. Now, what is the first term? Total tension on the block. What is the total tension on the block? T, 2T and 2T. This is the mistake most people do. That T is not the tension in any one string. That T is the total tension on the block. That's it. That was the only trap in the question. So T plus 2T plus 2T ka whole square by K equivalent. Then it is standard stuff. T square by K1, 2T square by K2, 2T square by K3, T square by K4. So this term here is the total tension on the. See, that's what I'm saying. You can take T anywhere you want because the T is anyway going to get cancelled. And then you're done. You'll get K equivalent from there and you can solve. All clear with this? There you can see the different springs, how it is playing around. Let's see one more question. Last one for the day. So every time you won't only get springs, you can get other stuff also. Let me show you a question where springs are not involved. We have an insulated container. We have a piston here of mass m. Area A. It's an insulated. It is smooth and insulated. So heat does not flow through the piston. So on the left-hand side, we have P0, V0, T0. We have helium gas. On the right-hand side also we have P0, V0, T0. Let's put it helium gas only. I could put anything, actually oxygen also. Now, if I move the piston by small x and release it, it will start oscillating. Think about it. If I push the piston to the right, this gas will get compressed. The pressure will increase. So it will push the piston back. Find the time period for small oscillations of the piston. Finish off, last one for the day. So don't think every time they'll ask in springs only. You can play around. This is what I was saying. You can literally bring any chapter into SHM. Again, small oscillations, okay? Too much oscillations, it will not be an SHM, it will be oscillatory. Let's see how do you handle this. Thermodynamics and SHM. How do we start this? So let's say you push the piston by a small x. So initially it used to be here. Now you pushed it by x. So then what would happen? This gas will undergo adiabatic compression. And this gas will undergo adiabatic expansion. So both are adiabatic process. And let the pressure become P plus dP1. And let the pressure become P plus dP2. Now, don't worry about it. Like, dP1, dP2, the signs will take care of themselves. Now, since this is an adiabatic process, PV per gamma is equal to constant. Right? And gamma is how much? 1 plus 2 by F, degrees of freedom. Differentiate on both sides. We have done this differentiation multiple times. dPV per gamma plus P gamma V power gamma minus 1 dV is equal to 0. From here, you end up with dP is equal to minus gamma P by V dV. Right? And so that's your dP, the change in pressure. Now, for the first gas, dP1 will be minus gamma P by V, dV will be A into minus dx because the volume decreased. So the pressure actually increases on the right hand side, gamma Px by V. For dP2, I'll just take it as gamma 1, gamma 2 if there are two different gases. Minus gamma 2 PA, here the volume increased, so A into X by V. So you'll get a minus sign, minus gamma 2 PA X by V. In this case, gamma 1 is equal to gamma 2. So did you see the signs will take care of themselves? I took here plus, but because it expanded, it becomes negative automatically. So then you're done. So now draw the FBD of the piston. P plus dP1 into area. So they can give you one side oxygen and one side helium into area, and this is acceleration. PP will cancel. You'll end up with dP2 minus dP1 into area is equal to mass into acceleration. Maybe I'll show this in the next page. And what is dP2? dP2 is this guy. Minus gamma 2 P A X by V. This will be also minus. So minus gamma 1 P A X by V is equal to mass into acceleration. So we get acceleration is equal to minus gamma 1 plus gamma 2 PA by V into X. Right? So there is one more A there. So A square. Yeah. Mass. Perfect. We got everything. So that's your omega square. Therefore, the time period will be 2 pi root over mass into initial volume V naught by gamma 1 plus gamma 2 P into A square. That's your time period, everyone. Clear how we played around with this? So where did we use this small x? Differentiation, isn't it? When you say dp is the change, you can differentiate only when the changes are very small. Clear? So this is a small change in pressure for a small change in volume. There, that's how we can bring thermodynamics into it. And you can substitute gamma 1, gamma 2 values and you're done. Clear with this? So next class when we catch up, we will do few more problems on this. I'll show you some more on the circular motion, some more on this thing, what do you call fluid mechanics, and then we will see rotational mechanics based SHM. So SHM literally, like I said, keeps popping up everywhere. Okay, that's some good thing. Today we did some really good ones. So this is one really good one. This equivalent is good. Yeah, literally like half the problems we did are these are all advanced problems only from this point. So all these are mains ones. Okay, the starting 4 or 5 questions were like good ones. They're not bad, but they're like mains and bits perspective. But after that, the next 4 or 5 questions are proper advanced level. So we should definitely give them a try again. Make sure to do them, getting it. Just don't read the notes. Take a rough paper and solve. If you don't do that, you'll not remember them. Okay, with that, we'll wrap up for the day. So I'll see you guys again on Tuesday. We'll continue from here. And do remember, there's a test online tomorrow night till 11:30. So make sure to give. It's a complete advance, this mechanics ka paper. So all the old topics will get revised. So any doubts, anything else, please stay back and ask, or else you're free to leave. I'll see you again next Tuesday. So take